Hello, and welcome to Amazon Web Services Webcast, Introduction to Amazon RDS, Low Admin, High Performance Databases in the Cloud. Before we begin, I would like to walk the audience through a few items. In your browser, you can see a Q&A chat pod. Please submit your questions for our presenters at any time during this webcast, and we will address them in the live Q&A session at the end of the presentation. Today's webcast is being recorded, and we will send you a follow-up email with the URL to the recording, as well as a link to the presentation deck. And again, welcome to today's webinar, Introduction to Amazon RDS, Low Admin, High Performance Databases in the Cloud. Our presenter today is Brian Rice, Product Marketing Manager with Amazon Web Services. Brian, you have the floor.
Thank you so much, Anna. And thank you to everyone who's joining us on the line. By the way, I'm joined by Pavan Poltukuchi and Sergey Sokolenko, who are Senior Product Managers with Amazon Web Services. And they'll be assisting me with answering your questions at the end of the presentation. Once again, thank you so much for joining us. If you are interested in learning more about what we talk about today, I want to encourage you to consider coming to our one of our many free summits that we are having around the world over the next several months. These are one-day-long events where you can enjoy a keynote from an AWS leader and also breakout sessions across all interests. For example, I will be in San Francisco on March 26th. I'll be delivering a superset of this presentation, which introduces participants to the entire range of AWS's database services. Frankly, before me, the more exciting act will be a keynote from our Senior Vice President, Andy Jassy. These events are at no charge. I want to encourage folks to visit the URL shown on their screen, and we'll also include this in the URL list that goes out at the end of the presentation to learn more, and we hope to see you there. Now, let's dive in. If you joined this webinar, chances are there's an application that you feel responsible for. And most likely, this application has a separate database. Now, running a database is a lot of work. There's a number of chores that you have to take on when you take on the responsibility of managing a database. It has to run on servers that need electric power, and they need cooling, and they need network connectivity. Those servers have to be acquired, which is often a time-consuming and bureaucratic process. They have to be racked and stacked and cabled when they arrive, and you have to be prepared to respond to failures 24 hours a day when hardware breaks. You have to install and maintain the operating system on these boxes. You have to install and maintain the database software on these boxes as well. You have to have a scheme for robust database backups. It's your responsibility to make sure that you don't lose data no matter what happens. It's your responsibility to make sure that those database backups themselves are secure, perhaps stored off premises or in duplicate. It's up to you to provide a plan for disaster recovery, for business continuity. It's up to you to provide a plan for scaling. What happens if we need to grow? What happens if our load is greater than we anticipated? Are we going to be buying hardware on an emergency basis? And finally, people from the application team are going to be coming to you asking questions about queries. Why is this operation so slow? How can we make the database respond faster to this part of the application? This is a lot of work. And the unfortunate thing about many of those tasks is that if you do them perfectly, nobody notices. That is the curse of infrastructure maintenance. Perfect jobs get no praise, and they don't really advance your career in a certain sense because they're not connected directly to customer value. Now, it sure would be great if there was a way to offload some of the undifferentiated heavy lifting onto somebody who could specialize in that. And as a matter of fact, the items listed here on the bottom of this heavy stack can be migrated over to Amazon Web Services. We have a lot of customers who run databases in Amazon Elastic Compute Cloud, also known as EC2. It's an infrastructure cloud. And we strongly support our customers running whatever databases they want inside of EC2 instances. This means that they don't have to worry about all of that hardware maintenance that they previously had to worry about when they were running on premises or in a colo space that they were managing. But there's still a lot of work. And again, a lot of the things listed in the gray stack there on the left are undifferentiated tasks in that they do not directly contribute to customer value. Well, this is why AWS also offers managed database services. So you can take a large fraction of those responsibilities and offload them to Amazon Web Services. What do you do with the time that has been freed up by taking away all this undifferentiated heavy lifting? Well, you use it to do those application optimizations you always wanted to do, but you didn't have time to do. This means that you can focus on things that improve your customer's experience. It's good for your customers, it's good for your career, and it's good for your company. Now, that's what all of AWS's managed database services are about. Let me sum it up for you. If you're running a database that you are managing, be it on premises or in an infrastructure compute cloud like EC2, you have full responsibility for upgrades and backup. What if there were packaged services that did these for you? AWS's managed database services, including RDS, provide these for you. What if security is a concern, as it virtually always is? If you are running in a colo or on premises, security is completely your responsibility. Now, if you run inside of AWS, first of all, you get to benefit from AWS's incredible investments in infrastructure security. Because of the scale of AWS, the company is able to invest in security measures that would be beyond the reach of most people doing their own self-hosting. Also, the company has invested in achieving certifications such as SOC 1, 2, and 3, HIPAA, PCI DSS, ISO 27001, and many more. These are a lot of work, and when you're in Amazon EC2 or Amazon RDS, they come along for the ride. Amazon Web Services also provides tools to ensure database security when you're running in a managed service, and we'll be discussing these later on in the presentation. These tools are provided for you, and it is your privilege and responsibility to use those to ensure the security of your application. Like I say, I'll go into more detail on that in a few slides here. When you're running self-managed, you have full control over the parameters of the server itself, the operating system on it, and the database on top of that. With Amazon RDS and our other managed services, we provide an appliance experience. We provide a service that is packaged, and we precisely document what we provide on behalf of the end customer and what our end customers can do. The advantage of having an appliance service is that it makes it really easy to automate. Suppose that you would like to automatically clone an entire database deployment on a regular basis. Well, in physical systems, that is a lot of work and very expensive. With a managed service, it's a matter of a few mouse clicks. That is the benefit that the appliance nature of managed database services like RDS delivers. Finally, let's talk about replicating data. Database replication is a very complex topic. You can get a PhD in database replication. Most people simply want it to work. So that's why our database services provide packaged services that deliver failover in the event of a service disruption. This means that all you have to do is click the button to enable, and AWS takes care of the rest of it for you. So let's drill down now into the specifics of Amazon RDS. RDS stands for Relational Database Service, and this is our managed SQL service. It's incredibly fast to get started with. Launching a new database instance, which is a virtual machine running RDS as an appliance, is simply a matter of a mouse click to launch, and it's up within minutes. We provide a variety of tools for scaling that online. In the physical world, scaling database servers is a lot of work. It's very expensive. It requires considerable advanced planning. And you have to do all kinds of capacity management guesswork to make sure you get it right. But with RDS, there are options that let you scale up and down. So that means you can take the risk out of scaling. There are package services for applying critical security and functional patches to the database software into the operating system, packaged offerings for backup, and packaged offerings for replication, enabling them with a mouse click. RDS is compatible with your applications because it gives you a choice of 4 database engines inside of RDS. We offer MySQL, Postgres, Oracle Database, and SQL Server. The performance is fast and predictable. I'm going to discuss in just a moment how you can choose the level of performance that you wish to provision for. And your application will receive that level of performance from the database for the lifetime of its run. Best of all, there's no cost to get started. There's no upfront investment. Instead, you're only charged for what you consume. And when you want to stop using a database, just turn it off. And your billing stops. This takes a lot of the risk out of launching new projects and out of experimentation and innovation. Let's talk about a few customers who rely on RDS every day. Flipboard is a very well-known property these days. They're among the most visible content aggregators. I myself love to use Flipboard on my phone to keep up with the news. RDS is a key part of their solution. They use our multi-availability zone capability, which I'll be explaining in just a few slides, to ensure the highest availability. Because of the fact that innovation is really, really fast on top of RDS, they are able to go from an idea on a napkin to an up and running and live project with a very small team in just a matter of months at a very low spend. That's a key part of what RDS delivers. But RDS isn't just used by startups. It's also used by some of the biggest enterprises in the world. For example, Samsung, when it was rolling out a media feature to go behind its smart TV line and its Blu-ray player line, chose AWS to build their solution on top of. They had originally been considering building a new physical data center solution to host this. Instead, they built it into AWS Cloud, and by using RDS and the other services we have to offer, they're able to save more than $30 million during the first 2 years. We have a lot of stories like this that we hear from our customers, and it just goes to show that innovation needs to be factored into planning. The ability to do something new rapidly at a very low cost is a key benefit of using managed services, and lots and lots of our customers have success stories just like this in this regard. So I mentioned a moment ago that RDS offers a remarkable degree of scalability. People often ask when they're considering getting on board with a managed database service, well, how do I know where to start? How do I know what kind of resources I'm going to need at the very beginning? Well, one nice thing about Amazon RDS is that we offer a range of so-called instance types. You can think of these as virtual server configurations with numbers of virtual CPUs and amounts of RAM. The nice thing about RDS is that you're not locked into your initial choice. You can scale up or down with just the click of a mouse later on. If you, through monitoring, for example, you determine that you need more CPU capacity or you need more memory. This would be very difficult to do with on-premises hardware. Typical hardware vendors don't let you give back a server and get a new one. Or you can shut them down and install new memory or maybe even add CPUs. But the downtime and the risk is considerable. The amount of storage that is allocated for your database is also scalable on demand. And as a matter of fact, the scaling of storage is online without a performance impact, except for the SQL Server engine. There are two choices for storage, standard and provisioned IOPS. And we recommend provisioned IOPS for most of our customers. The reason why is that provisioned IOPS offers you the opportunity to choose a rate of IOPS, a rate of input-output operations per second, and that will be delivered for the lifetime of your application. If you have an application that does not require consistent high levels of performance, you can save a little money by choosing standard storage instead. But if you're running a production workload, provisioned IOPS is probably going to be the right choice. So here's a very simple application architecture. We have at the very bottom a database instance, and the letter M means that this is a master. Connected to it is an application running in Amazon EC2. And on top of that, there is an elastic load balancer, also provided by AWS. Now, if you are newer to AWS, you might be wondering why I, in this diagram, have a load balancer when there's only one server underneath it. The reason is that this gives you not only the opportunity to scale your number of application instances as the load on that tier increases, but it also allows you to take advantage of a very simple piece of functionality. You can even configure EC2 to scale to one instance. So in essence, you can have automatic restart of the instance if it halts for any reason. Because it's behind an elastic load balancer, it won't result in a change of the application's presentation to the internet. In other words, it'll still be at the same IP address. So in any case, this is a very simple application that a lot of our customers get started with, and it delivers all the benefits of RDS, the ability to scale online, the ability to have automated backups, such as we'll discuss in just a moment. But we can take it farther, and you'll see this picture again as we go forward. I mentioned just a moment ago backups. RDS offers not one but two techniques for getting backups, either with the click of a mouse or with a simple API call, or even on an automated basis with no manual intervention at all. First of all, let's talk about automated backups. These allow you to roll back your database to a particular point in time, and they are enabled by default. The default retention period is 1 day, but in fact, you can choose to grow that out up to a maximum of 35 days. So this means that your database is protected from application error, administrator error, and this is especially useful when you're in a test dev phase with the application, because you can roll back to a particular point in the database's operation in a consistent fashion. The other way to make sure that your data is highly available and highly durable is to keep and maintain manual snapshots. Unlike automated backups, these occur when you request them, and they stick around until you explicitly delete them. They are stored in Amazon Simple Storage Service, also known as Amazon S3, which is an incredibly durable place to store data. Data in S3 is automatically replicated across multiple data centers, and it gets the benefit not only of the low prices of S3, but also the fact that S3 is designed to deliver 11 nines of durability. That means 99.9999999% durability on an annual basis. That is a great way to make sure that that your data is recoverable to under almost any conceivable circumstance. These snapshots are exceptionally useful because each of them can be used to instantiate a brand new database. I've mentioned several times the value of enabling experimentation, of making it easy to try new stuff, to try a totally new application architecture, or try a tweak to your application with real data in a test environment. Well, a lot of our customers use these manual snapshots to clone off an instance of their database so that they can try new things. It's an incredibly valuable feature. I mentioned multi-AZ operation about 5 minutes ago. Let me explain to you what that is in more detail. First, you need to know the term availability zone. This is an AWS term that we use to mean a physically distinct and independent compute infrastructure. If you like, you can think of availability zones as basically a data center. We don't use the term data center because an availability zone might actually be implemented with several distinct data centers with high latency links between them. Nevertheless, each of our regions around the world consists of multiple availability zones. We offer an option with RDS to allow you to have your database synchronously replicated to another availability zone that is in the same region. It's a synchronous replication, so you know that the data is consistent, and failover occurs automatically in the event that anything happens to the primary. In the event of database failure or hardware failure or any other type of service disruption, we'll fail over. And the way we do that is by changing the IP address that is behind the DNS name of the endpoint. So typically, failover occurs within a very few minutes. Even if you don't plan to operate your compute in multiple availability zones, it's still very desirable to run in a multi-AZ mode. The reason why is that scheduled maintenance, such as, for example, the application of security patches, is always applied to the standby first. That way, you minimize the impact of the application of patches. It just becomes equivalent to how long it takes to achieve that failover from one AZ to another. Just a few minutes. So let's take multi-AZ and add it in to our sample architecture. And we'll also add in the database snapshots that I described a moment ago. Here on the slide is a highly resilient and durable application that is still very, very simple. We've added multiple application instances to the middle tier, and we have added down on the very bottom a multi-AZ standby for our database, which is ready to take over in the event of any disruption in service of the master. We've also set up our system, perhaps with a little script that uses API calls to regularly save database snapshots in Amazon S3. They're persistent until we choose to delete them, so that goes beyond the capability of the automated backups that RDS provides automatically. Suppose you'd like to take it even further. Here are some ways you can make RDS do more for you. A lot of our customers use read replicas to offload write traffic from their primary database. You'll configure one or more read replicas, the maximum is 5, and you tell your application instances to do their read traffic against the read replicas rather than against the primary. So this gives you a lot more performance headroom, and they're incredibly easy to set up with RDS. You can also do read replicas with the native database layer. For example, down here at the bottom of the slide, on the left, you see a snippet from the documentation of MySQL that lists all of the activities that are required to set up a read replica. In RDS, it's a click and a pull-down menu. Incredibly easy to get started with. Read replicas are available for Amazon RDS for MySQL. There are other ways you can use RDS's appliance-like nature to get benefits of durability and ease of migration that go beyond what we've talked about before. I mentioned that you can take a database snapshot. By default, these database snapshots live in the same region, the same AWS region as the database themselves. This is a very important security tenet for us. Data never leaves an AWS region unless you explicitly request it. We have a feature in RDS that allows you to take a database snapshot and copy it across the world to a different AWS region. You can use it as a warm standby for disaster recovery, or if you're planning to migrate your application to a different region, you can use it as a starting point. The data transfer is done in a secure fashion, and this is a great way to prepare in advance, for example, for anticipated weather disruptions in a given area. It's a great way to get ready to bring your data closer to your customers in the event of global expansion. And it's available for all of our database engines. I should mention that it's not available for Oracle if you're using transparent data encryption. And it's also not available in GovCloud, which is our dedicated cloud for U.S. persons for the U.S. government. Now you can even take cross-region snapshot copies one step farther. Amazon RDS for MySQL supports cross-region read replicas. This allows you to bring your live data even closer to customers around the world and to have even faster recovery in the event of a regional service disruption. And of course, it's always possible with a read replica to quickly promote it to a master database instance so that it can start handling write traffic and be an independent database. This works for cross-region read replicas as well, and it's a great way to migrate data rapidly and easily around the world. And this is available for RDS for MySQL. Everybody always wants to know how much it costs, and I'm glad because the cost structure for RDS is very simple and easy to explain. Our AWS customers get a monthly bill, and it's always based simply on their consumption. So I have a worked out pricing example here for you on the slide. Let's say that you want to run a particular database instance type we call an M3.xlarge. Incidentally, this happens to have 4 virtual CPUs and 15 gig of RAM. You can find on the RDS website a complete table of all the database instances that are available. So for purposes of the pricing example, let's say you're running MySQL, you're running it in our Oregon region, and you're running in single AZ mode. Let's say that you've provisioned 100 gigabytes worth of storage, and let's say you chose provision DIOP, and let's say that the rate you provisioned happened to be 1,000 IO per second. So the on-demand price for a db.m3.xlarge instance in that particular region is 60 cents. Each gigabyte of provisioned IOP storage costs 12.5 cents, and each 1,000 IOPS you choose to provision costs a dime. So if we assume that there's 720 hours in a month, your monthly bill works out to about $550. Remember that this is an all-in price. For this, you get power, cooling, human beings to tend it. You get maintenance in terms of making patches available for installation. You get the opportunity to take snapshots. You get the automatic backup capability. It's all bundled into that price. And remember that this is all at no obligation. If you decide that RDS is not the right solution for you anymore, you can just shut it down and your bill drops to 0. Suppose you'd like to save even more money. We have a billing option called reserved instances. Keep in mind that a reserved instance is not like a regular database instance in that it's not something that you have to plan to buy and configure ahead of time. You should think of a reserved instance as being like a Groupon. If you buy this Groupon, then you get to apply a lower price to any running instance that matches the description on the Groupon. That means, for example, that you pay a little bit more and you get a much lower price as the time goes on. Remember that I showed you an hourly price for an M3.xlarge instance purchased on an on-demand basis on the previous slide of 60 cents. Well, that same hourly price when you bought a reserved instance is less than 20 cents. So there's considerable per hour savings available. At the bottom of the slide, I have a worked out example for a particular type of reserved instance called the so-called heavy, and I'll explain what that is in just a moment. And I have a cumulative table there of your total spend. You'll notice that where the arrow points, you're already saving money on a cumulative basis. You've already broken even with the 5th month of using the reserved instance. This is a great way to minimize your spend, and we provide a lot of choices. We have heavy, medium, and light reserved instances. These correspond to how much of the day or how much of the billing period the instance is up and running. If you're running a production database, you probably want heavy reserved instances because these are priced on the assumption that the reserved instance is running 24 hours a day. If you have persistent needs for database instances for test and dev purposes, for example, or if you have an intermittent workload, you can save money as well by choosing light or medium reserved instances. Keep in mind that these are flexible. They are not tied to any particular instance. Rather, when you buy a reserved instance, you specify, I want a particular instance type, I want a particular database engine, the choice among Oracle, SQL Server, MySQL, or Postgres, and you specify either single or multi-AZ. From then on, for the lifetime of the entitlement, you get the better hourly rate on any instance that matches. So they're a very, very flexible offering. I mentioned a while ago that scaling in your own data center is a lot of work. It means purchases, it means planning, it means scary capacity forecasting. It sure would be great if there was a way to take all of the guesswork out of capacity by making it so that you can get new capacity on demand. Well, that's what RDS delivers. You can scale your instance types. If you need more CPU or more memory, notice that you can go all the way up to 32 virtual CPUs in a given instance. Or you can scale your memory all the way up to 244 gigs. You can scale your storage. There's an error on the slide. The storage down is not you can't do that through the interface. But typically you need to scale storage up because you are running out of capacity, and that is an online action that does not require downtime. You can move your traffic to read replicas to reduce the load on the primary. A lot of our customers put an in-memory cache in front of Amazon RDS. Such as Amazon Elasticache, our managed caching service. You have the choice of Memcached or Redis. These are very popular open source in-memory caches that we offer as a packaged appliance inside of Elasticache. Or you can run your own cache self-managed in EC2. Finally, you might need to shard your database, that is to partition it based on some attribute of the data. Sharding in physical servers is incredibly painful because you have to manage and maintain physical hardware and map that to application logic. So with RDS's capability of running database instances as appliances that can be stamped out like cordwood, sharding becomes a lot less painful. So you see, RDS opens up scaling opportunities that are simply not possible on physical hardware. I'd like to share a few best practices for you. We recommend provisioned IOPS storage for basically every production workload because of the ability to choose a level of I/O operations per second that will be delivered for the lifetime of the service. Another key benefit of provisioned IOPS is billing predictability. If you choose provisioned IOPS, you're billed not on how much I/O you use, but rather on the level that you provision for. That's different from our standard storage, in which you're billed on a per 1 million IOs basis. We also strongly recommend multi-AZ deployments because of the fact that they are protected from scheduled maintenance downtime to a certain extent by the fact that we do that scheduled maintenance always on the standby first. We encourage all of our customers to make maximum use of the way RDS lets you spawn off test environments rapidly. If you're planning a big change to your application, it's really smart to spin up a clone of your database and test that application change against it first before you go into production with it. It's really a great source of peace of mind to know that you're doing your testing with real data. And the cost of this, assuming that you spin it up when it's needed and shut it down when it's needed, can literally be no more than what you buy for pizzas on launch day. We encourage you to build database snapshots on a regular basis. Remember, they're stored in Amazon S3, so the price per gigabyte is incredibly low, and we encourage you to test recoveries from them. Finally, we encourage you to configure notifications of various types. There are two kinds of notifications available for RDS. One of them is CloudWatch, which lets you know about load thresholds. If you're running cross-region read replicas, for example, they'll let you monitor the lag in the replicas from one region to another. You can also configure yourself to receive database event notifications, such as planned maintenance activities and failovers. Make sure that these are all set up for you. Now, this talk would not be complete unless I addressed the incredibly important topic of security. Earlier, I talked about the security benefits that the AWS environment delivers. I'd like to make it clear that security is a shared responsibility between our customers and AWS. AWS delivers a physically secure infrastructure, and our customers are required for correctly configuring their instances for secure operations. We have a variety of tools for doing so. We have database security groups which allow you to lock down who can access, which IP address ranges can access your database instances. If you like, you can use Amazon VPC, our virtual private cloud offerings, in effect to extend your on-premises compute environment into AWS. It's very, very important to maintain a fine-grained control of who has access on the database and what they can do. I can tell you that one of my proudest achievements in the world of database was to accidentally delete a running Oracle database. It was one of the worst days of my career, and if we had been operating in Amazon RDS, AWS Identity and Access Management would have blocked me from that huge blunder. It's very, very important to design and implement a least privilege environment, and AWS IAM makes it easy. And of course, just like with any database implementation, we have a concept of database master users, which allow for authenticated access by applications to the database. If you'd like to move data into RDS, there's a variety of techniques that vary based on your choice of the engine. These are all very common tools. Rather than dive into detail on all of them, I'm just simply going to sum them up. What you want to do first is a bulk copy of the vast contents of the previous source database. And of course, unless you have the opportunity to take downtime on that database, it may be undergoing change while the dump is in progress. So that means that there's going to have to be a separate catch-up step to reconcile the changes to the database that occurred while the migration dump was in process. So here on this slide are the simple techniques that gather the vast bulk of the data. And then you need to true up the changes. And the overall theme of these choices is to replay transactions against the migration target. Be aware that particularly for the commercial database engines, there's a wide variety of great partner-based solutions that can help make database migration a lot easier. In general, though, you'll want to make sure that you have a plan for truing up those changes that occurred during the migration process. If you choose one of these commercial solutions, then chances are that's going to be taken care of for you. Let me sum this up. Why should you choose Amazon RDS? Take a look at these lists here. The work on the right, if you are an experienced database person, probably doesn't look fun to you. The undifferentiated heavy lifting of running databases, the stuff that nobody notices if you do it perfectly, is what Amazon RDS takes care of for you. It lets you focus your time and your team's time on those aspects of running a database that actually help the application and deliver value to your end customers. such as optimizing queries and making sure that your schema design is just right. It's even possible to get started with RDS at no charge. We have a so-called free tier, which is a year's worth of free use of Amazon RDS. It allows you enough hours in the course of every month to run our smallest grade of instance type continuously, as well as 20 gigabytes worth of storage and enough backup space to back it all up, as well as up to 10 million I/O operations per month. If this doesn't look like enough to you, keep in mind that pricing example that I showed several slides ago. Even if you go outside of the database tier, this is a very low-cost offering, and we even offer billing alerts so that you can be notified rapidly if your bill crosses certain thresholds, so you can take action. There's a variety of resources you can use to learn more. The RDS homepage is a great place to start. It includes a detailed set of frequently asked questions that will help you learn more about the service. And in particular, I'm pointing to item number 9 in our FAQ document. That link there will take you to our import guides, which give you very precise information on how to migrate data into each of the engines. I want to thank you very much for investing your time in joining us for the presentation so far. My colleague Anna has a number of poll questions for you that we will be very grateful to your response to. And then after that, we'll do some Q&A. So let me hand the floor back over to you, Anna.
Thank you, Brian. On your screen, you will see our first poll question. Give you a few more seconds. Thank you. One moment. Our next poll question. Great. Thank you all very much. And lastly, one of our final poll questions. Great. Thank you very much for completing the poll questions. I'll now hand it off to Brian and team for question and answer.
Yes, indeed. We're back with Sergey and Pavan and me, and we had a large number of questions, and we have a limited time remaining, but we will do our best to respond to as many of these questions as we possibly can.
Okay. So the first question we have here is the standard MySQL replication between availability zones, or is there a true multi-master RDS available, like MySQL with the Galera patch? So I can take this question. So I think the question is referring to multi-AZ deployments which synchronously replicate data across availability zones. So the multi-AZ replication that RDS uses is physical, and it's not either MySQL's native replication or a third-party replication like Galera. However, the secondary or the standby instance is not available for read access, given that the replication is physical. Okay.
I'll take the next question. Lim is asking how the patches are being applied and whether users have the ability to specify the particular patch level. RDS automates the application of patches. For MySQL and Oracle, you could choose your patch level that you would like to run on. You can also select the minor patches to be applied automatically. For that, we have an option in the database creation wizard that can be easily applied to your database instance.
I'll take a question here. There is a question about about migrating a data warehouse into RDS. Well, migrating data from a data warehouse into RDS would be the same kind of migration task as migrating from any other database source. However, I would encourage people to consider the use of Amazon Redshift for running a data warehouse in AWS. Amazon Redshift, unlike the engines in RDS, is a columnar-based store. So that means that it's optimized for data warehouse type operations. I would encourage you to learn more by going to the AWS website and go to choose Redshift.
I'll take the next question. So we have Peter Vogel asking, does RDS support multi-master MySQL replication across regions like Percona or MariaDB? So RDS does support cross-region replication, but it is not multi-master. It is master-slave. You can create a master in region 1 and create a replica in a different AWS region through read replicas. So with read replicas, RDS uses MySQL's native replication technology to support that functionality.
I'll go with the next one. Scott is asking about the largest database sizes that we support. The answer is simple. For Oracle, MySQL, and Postgres, our maximum database size is 3 terabytes. You could also, and the maximum size for SQL Server is 1 terabyte. If you would like to support larger database installations, you can choose to shard your databases and that way support even higher number of even larger databases.
I'll take a question. We were asked, if I use RDS for 45 minutes, will I be charged for 1 hour? And the answer is yes. We charge for 1 hour or any increment thereof.
Okay. So I'll take the next question. Can the rollback feature be in hours instead of days? So I think the question is probably referring to point-in-time recovery functionality. So with point-in-time recovery, if you have a backup retention period set to, you can set it anywhere between 1 to 35 days. And once that is set, you can create a new instance using point-in-time recovery functionality using a specific time within the last 35 days and perform the operation so that you can create a new instance as if it were at that point in time that you have selected. So the time granularity could be up to seconds.
Michael is asking about time zone settings on RDS and whether we support selecting a specific time zone. Happy to tell you that with Oracle, we began offering users the ability to choose time zones, specific time zones. Check out our website. You'll see information on Oracle time zone settings on there.
I'll take the question. We were asked, do we have an AWS Summit in India? If not, any plans to do it? Well, I can't announce any new plans, but we are aware that we have a large number of AWS customers in India, and I would encourage you to keep checking back on the Summit website.
Okay, so I'll take the next question. Currently, RDS limits to M3.2 extra large. Is there any plan to support C3.8 extra large or higher instance types. So we have M2 family that supports M2.4 extra large, which has 64 plus gigs of RAM and a lot of CPU horsepower available. In addition, for MySQL 5.6, we support CR1.8 extra large, which has 254 gigs of RAM and a lot more CPU than M2.4X4.
We had a question about, is it possible to migrate a database from MySQL to DynamoDB and vice versa? We haven't talked about DynamoDB yet in this webinar. DynamoDB is our managed non-relational database. It's for those applications where you don't need the power and flexibility of the SQL framework, like joins and data constraints and things like that. Instead, you want the simplicity and the limitless scaling that a NoSQL database provides. There's really no way to automatically migrate from one to another. It's typically changing from any SQL database offering to a NoSQL database offering requires you to take another look at your application architecture. We typically encourage folks who are encountering scaling problems with a relational database first to consider the various scaling tools that RDS makes easy. Like, for example, the fact that it's easier to shard, the fact that you can have read replicas, the fact that you can put Elasticache in front of your database, and then only consider migrating that application to a non-relational database as you start to see the end of the viability of those techniques. For applications that you're designing brand new, if you don't anticipate a need to have a relational paradigm, getting started with DynamoDB is very easy because it has a simple interface and a simple operational model.
Okay, so I'll take one question. Is there a chance to replicate MySQL from RDS to MySQL instances in our own data center, or the other way from MySQL instances in our own data center to RDS? The answer is yes. For MySQL, across all versions of MySQL, you have the ability to set up replication between your on-premises instances or external instances to RDS. However, on the replicating out, as in using RDS as a source and an external instance as a target, that is only supported with MySQL 5.6.
Bakhtiar is asking about a free tier for RDS. Yes, we do offer Amazon RDS on a free tier. You can run a T1 micro RDS instance for the entire year for free to evaluate it for your needs.
There was a question about are there limits on the number of database instances running in RDS? By default, we limit a given customer to 40 instances running within RDS. However, if you need more, all you have to do is fill out a form and tell us how much more capacity you're looking for.
Okay, there's another question. Any plans to allow users to change time zone settings with RDS? Currently, you can only use RDS on a machine with the same time set as UTC. Oh, looks like my colleague here already covered it. I was spaced out. I will take another question. For replicating to or from RDS, is there a technical how-to on this topic that you would recommend? Absolutely. So our documentation has a very elaborate section on setting replication from and to RDS. Please check that out, and if there are any follow-up questions, please report that on our forums and we'll respond.
Well, I think we have time for about one more question here. How about can we use Puppet and Chef scripts on RDS? Well, for those of you who aren't familiar with Puppet or Chef, these are packages that allow you to deploy an entire computing infrastructure in a scripted fashion, and applying configuration at the time of installation to the innards of a compute instance or a database instance. Lots of people use Puppet or Chef to push an entire application and database stack live, configuring each of the components as it goes. Now, you should be aware that RDS is an appliance, and that means that you're not going to be configuring the internals of an RDS instance in the way that Puppet or Chef do. However, we do strongly encourage the API-based use of RDS using scripts. For example, we encourage people to use CloudFormation, which is the AWS tool that allows you to deploy an entire application stack, including RDS instances, in a reliable and repeatable and guaranteed no fat finger slips on the keyboard kind of way. It is also possible to tell tools like Chef and Puppet to reach out and give birth to RDS instances in a scripted and programmatic fashion with externally provided parameters. Okay, and with that, we want to thank everybody who gave up their time to talk with us about RDS today. We're going to send out a follow-up email with more links and more information. Once again, we're very grateful to you for joining us, and we hope to see many of you at an AWS Summit very soon.